Greetings, everybody. So I've gotten this question twice in just a few days, and for that reason, I thought it'd be important to make a video about it. And what you're seeing here is an actual screenshot from MyMathLab, and it's a question from assignment 2.1, kind of later in the assignment, but nonetheless, it's something that you'll encounter in the assignment. Now, although I have the screenshot here of the question because I want you to understand what I'm about to talk about, I don't actually want to work the question as it is in this form on MyMathLab. I'd like you to try to do that based on what I show you. Okay, so I've adapted the question. I've changed it just a little bit. It's still the same premise, still the same method of solution, but I've got the numbers a little bit different. Okay. So it says you're planning a 4-day trip to Seattle. On each day, it could be either rainy or sunny. Okay. And we'll just have to accept that those are the possibilities. That's the premise of the question. And more importantly, it says that each day it's equally likely to be rainy or sunny. Okay. So rain's not more likely than sun, and sun is not more likely than rain. Okay. So it's a coin flip, 50-50 shot either day. Any day that it could be rainy or sunny. What's the probability that it will rain on exactly 3 days? Now, here's the strategy that I am going to recommend to you. I'm not saying it's the only way to do it, but this is what I'll show you because I want to emphasize something called the sample space. Okay, so anytime we have a probabilistic event, then there is the set of all possible outcomes, and that's what we call the sample space. And I'll take that approach on this one. I'm going to write out the sample space, which is just every possible outcome that could happen if you go to Seattle for 4 days, and it could either be rainy or sunny on any particular day. So I've organized that in the table, and you notice that the S stands for a sunny day and R stands for a rainy day. And notice that each one of these has 4 letters, either S or R, and that I've arranged it to keep track of all the possibilities. Like 4 S's means that it didn't rain on any day at all. It was sunny 4 days. Okay. And then in this row, this is what it would look like if it rained 1 day. That's every single way that it could rain one of the 4 days. Rain on the first day, rain on the second day, third day, fourth day. Okay. And then in this row, that's what it would look like if it could rain on 2 days. That's every possible way that it could look like if it rained on 2 days. Okay, so notice like I've gone through and I've included every possible arrangement of raining on 2 of the days. And here's every possible arrangement of being there 4 days and getting rain 3 days. And then here's what it would look like if it rained on all 4 days. There's only one possibility. Okay, so if from here, with this being every possible outcome, with this being the sample space, I can calculate the probability that it will rain on 3 days as the number of ways it could rain on 3 days over the number of possibilities in total. Okay, so all right, if I count on this table and I go look at the row that says, well, what's it going to look like if it rains 3 days? There were 4 ways that could happen. All right. Okay. But there were, if you count them up, all possibilities, 16 total possibilities. So I get 4 out of 16. If you were asked to reduce that, then you could say, 1 out of 4 or 0.25 if you needed a decimal. So it's like a 25% chance that you go to Seattle for a 4-day trip and it rains on 3 of the days. Okay. All right. So that is how I'll recommend you go about this one. This one will be even easier because it's just a 3-day trip and it will be much easier to write out the sample space. All right. But that's how you can do it. Now, you can only do it this way if every outcome in the sample space is equally likely. And that was one of the premises of the question. To contrast that, I have this question here which is going to sound a little bit like the one that we just did, but it has one very different detail. Okay, so say in the summer in Fort Worth, Texas, each day it will either rain or not rain. Okay, we can agree with that. Therefore, is the probability it will rain on any day 50%? I mean, the sample space is rain and not rain. Okay, and if we were treating it like this one, there's like one possible outcome where it rains, but two possible outcomes total. Why can't we take the same approach here? It's because each event in the sample space is not equally likely. I mean, there might just be two events in the sample space. It either rains or it doesn't. But I mean, these are nowhere near equally likely, not even close. Okay? So the only reason that we can do this problem this way with the sample space is because the premise of the question is that each event is equally likely. But anytime that's the case, anytime each event in the sample space is equally likely, then we can just do a simple division like that, and it gives us, I think, in some cases, a fairly easy way to answer the question.